Welcome to the Bentley Systems training course, where you'll learn how to design concrete shear walls in RAM concrete. Before we design the concrete shear walls in RAM concrete, let's first review the correct workflow for designing concrete structures in RAM structural system. The building models are created in the RAM modeler, which will contain the three-dimensional model of the structure, including all members, loading information, slab and deck assignments, and story data. If your model contains any gravity steel members, the gravity steel members must be designed in RAM steel beam and RAM steel column before proceeding. After that, the lateral analysis is performed in RAM frame, where the lateral loads are generated and the full three-dimensional frame analysis of the lateral load resisting system is performed. Next, the gravity analysis is performed in RAM concrete in the gravity analysis mode, which uses finite element analysis to provide concrete beam and column forces for all gravity loads applied to the structure. Finally, any concrete beams, columns, or shear walls can be designed in RAM concrete. So before the concrete shear walls can be designed, the gravity design for the steel members should be current to ensure that the correct member sizes are considered in the self-weight and seismic mass calculations, and the lateral analysis must be performed along with the gravity analysis to ensure that all of the concrete members or shear walls have their forces available for the design phase. For this series of videos, we will be using a sample model that's already been created in RAM structural system. We will now proceed to perform the gravity design on the steel members. We will perform the lateral analysis and the gravity concrete analysis, and this is all in preparation for designing our concrete shear walls. Over at the left-hand side of your screen in the RAM Manager, you're going to find your design toolbar, and this is kind of your roadmap for developing your proper workflow. So we're going to start at the top at RAM steel beam and work our way down to RAM concrete. In each of these modules, we're going to either go ahead and perform the design or the analysis. Now for RAM steel column. Next, we're going to go to RAM frame. Now, for the purposes of this training, we're going to assume that all of our criteria, diaphragms, and lateral loads have already been specified, and we're ready to perform the design. And finally, we'll proceed to RAM concrete and perform our gravity analysis in the RAM concrete gravity analysis mode. We are now ready to proceed to our shear wall design module. So we'll go to our Mode toolbar in RAM Concrete and select Concrete Shear Walls. This is where we will design all of the lateral concrete shear walls for our structure. To make visualizing the structure a little easier in this mode, I'm going to go ahead and turn off all the elements that are not going to be designed. So we're going to turn off all of our gravity members, including our gravity walls, as well as all of our lateral elements, except of course our shear walls. Our first step for designing our concrete shear walls in RAM concrete is to specify our design criteria. This will include setting up our design code, the design and general criteria, and also some coupling beam criteria. To set up your criteria, we're going to proceed to the criteria menu within the RAM concrete shear wall mode. The first criteria we're going to specify is our code criteria, and this will be used to design the lateral concrete shear walls. Here we're going to select the ACI 31811 code, and we'll click OK. Next, we will specify our design criteria. Here we can enter our clear bar cover and our bar spacing information. We can also enter some code options. Now, these are used to calculate the shear capacity of the walls and the spacing limits of your shear reinforcement. We can also specify our structural wall category, which will be used to specify if the wall should be designed as an ordinary reinforced concrete structural wall or a special reinforced concrete structural wall if seismic provisions would be necessary for your particular structure. We have our Ivc parameters, which are used to specify the CD and importance factor for your seismic parameters. And we have our SDC, our seismic design category information. We can enter our resistance factor for shear, and you would either specify this at 0.75 or 0.6 in the calculations. Lastly, we're going to enter our wall boundary ties. This is to specify the tie bar size for situations where vertical reinforcing is required to be confined by ties. For this training, we're going to assume that seismic provisions are not required, and we're going to leave the rest of the information set to its default. Next, we are going to specify our general criteria. The general criteria is used to specify if you want to store design results for the most critical load combinations or all of the load combinations. We're going to choose to store our design results for the 5 most critical load combinations. If you choose to want to store all your design results, please just note that storing a large number of design results will increase your program runtime. Lastly, we are going to specify our coupling beam criteria, which will be used to specify the global reinforcing criteria for all assigned coupling beams. We can either choose to use a uniform layout or to specify some longitudinal and transverse bars. We'll go ahead and specify our longitudinal and transverse bars. We'll say 2 layers of number 7s on the top and bottom, bars at the top. And for our transverse bars, we'll go with number 3s at 4 inches on center. After you're done, we can go ahead and click OK and then save.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.